Now let's look at 2023 AMC 10B problem 18 and 12B 15. So this is a number theory problem, and we are doing this fractional equation. But first, we need to convert it into the integer equation. Okay. So it's 15a plus 14b is equal to c. Okay. And here we notice that 210 is essentially the product of 14 times 15. And obviously 14 and 15 are relatively prime. Okay. So here we have three statements, and we need to decide which statement or statements are correct. Let's look at statement 1. So it says that if either A14 are relatively prime or B15 are relatively prime, or both of them hold. So basically it covers three possible cases. One is only A14 are relatively prime, but B15 are not, or vice versa, or both of them are relatively prime. So if any of these three conditions hold, then we can conclude that C and 210 are relatively prime. Is it true or not? Obviously, this is wrong. So why statement 1 is wrong? Let me give it a counter example. Let me simply set A to be equal to 1. So obviously, A and 14 are relatively prime, right? Okay. So now let me set B to be equal to 15. Then what we get is C is equal to 15 plus 14 times 15. Obviously, is equal to 15 squared. So it's not relatively prime to 210 because 210 has a factor 15. So statement 1 is wrong. Next, let's look at statements 2 and 3. So I want to first study statement 3, not 2. Let's see why. It's because for statement 3, let's look at only if part. So if the only if part holds, which means that if C and 210 are relatively prime, then it implies that both A14 are relatively prime and B15 are relatively prime. And then let's look at statement 2. So under the same condition that C and 210 are relatively prime, so the implications in statement 2 is just a subcase or the weaker result of the only if part from statement 3. So we can prove at least the only if part in statement 3. So it implies that statement 2 holds. Okay. All right. Given this reason, let me first look at statement 3 to check whether it is true or not. So we have to prove it in two directions. First, let's look at the if part. So for the if part, we have to show that if both of the following two conditions hold, then whether we can get the conclusion that C and 210 that are relatively prime, whether this is correct or not correct. Okay, so let's make a proof. So we will use the contradiction argument. Suppose that under the conditions on the left-hand side, we find C and 210 are not relatively prime. Okay? Suppose C and 210 are not relatively prime. And we recall that 210 is equal to 14 times 15, and these two numbers are relatively prime. So this implies that C must contain a fact, at least one factor that is a factor of 14 or 15, right? So with the law of generality, let's just assume that C contains a factor that is a factor of 14. Let's say it contains a factor 7. Okay. Let's say 7, device C. Okay. So what's going on next? Recall that ABC should satisfy this given equation. And now let me mark 7 on both sides of the equation. So the right-hand side is divisible by 7, and the second term on the left-hand side have a multiplier 14, so it's divisible by 7. But 15 is relatively prime to 7. So to make this equation hold, we need to have that 7 divides A. But if this is the case, then there's no way for us to have A and 14 to be relatively prime. So we get a contradiction. This completes the proof of the if part. So it says that the if part in statement 3 is correct. Next, let's look at the only if part in statement 3. So for the only if part, we need to prove the following result. Suppose we know that C and 210 are relatively prime. Then we need to prove that both A and 14 are relatively prime and B and 15 are relatively prime. Okay. All right. So how to prove this result? Well, let's do it in this way. Suppose, let me say, P is denoted as the GCD of A and 14. Okay. And for this red equation, let me modulo both sides by P and see what we get. On the left-hand side, for the first term, because P is a GCD of A and 14, so A must be divisible by P, so the first term is congruent to 0. What about the second term? 14. Again, 14 is divisible by P, so it's congruent to 0 modulo P. So it requires that P must divide the right-hand side C. So C is a multiple of P. But in this case, can C and 210 be relatively prime? No way. Because recall 210 is equal to 14 times 15. So here we at least know that P is a factor of C. But also we know that P is the GCD of A and 14. So it means the GCD of C and 14 times 15 must be at least P. Right? But recall that for the only if condition, we know C and 210 are relatively prime. So this number is equal to 1. So 1 is lower bounded by P. So it implies that P must be 1. So it tells us that A and 14 are relatively prime. By making a similar argument, we can prove that B and 15 are also relatively prime. So this proves the correctness of the only if part in statement 3. So the above analysis shows that statement 3 is correct. As I said earlier, statement 2 is a special case of the only if part of statement 3. So this guarantees statement 2 to be also correct. Therefore, the answer to this question is